Okay, new topic, linear transformations. A linear transformation is a mapping from some vector space V to some vector space W. It's a rule for taking every element in V to some element in W. Okay, a matrix, for example, does that. If we have a 7 by 5 matrix, it takes every element of R7, sorry, it's a 7 by 5, I'm sorry, it's a 5 by 7 matrix. The rows have length 7 and there are 5 rows. Okay, so it acts on column vectors with 7 elements because the number of elements in your column vector has to match the number of elements in your row, or you can't multiply the row by the column. Okay, so the matrix acts on elements of R7 and the results are elements of R5. And of course we've already seen that there's a null space and a column space and a row space, and there's one other space that we need to look at, but we're going to do that in the context of this study. Okay, so linear transformation from some space to another. You can think R7 to R5 as an example, but it could be from P7 to P5 polynomials. Okay, it could be between any two vector spaces. It could be from M23 to M23, space of matrices. In any case, a transformation is linear if when you apply it to two vectors in V, to the sum of two vectors in V, what you get is what you would get if you apply the transformation to the first vector, then apply it to the second vector, and then add them. Okay, and that's a fairly straightforward type property. It's kind of the property we hope for because it keeps things simple. Also, if you transform some multiple of the vector V, what you get is that same multiple of the transformed vector V. Okay, so if you transform 5 times V and then transform V and then multiply it by 5, it's going to come out the same. Okay, those are the rules for linearity. Just two conditions that you have to verify, and the verification is most of the time quite straightforward, but you have to know what to write down. So we're going to look at that next.